Hello everyone, welcome you all to the session of memory management. As we know that memory is one of the crucial and important resource of computer system, and it is a task of operating system to share this memory with ongoing processes very efficiently. So overall performance of the system should be optimized. So memory management is one of the important concept of operating system. So let us start the session. So let us see what is memory. As we know that computer memory is any physical device capable of storing information temporarily or permanently. Any device of the computer which can store the information, that is memory, and that memory can be a temporary or permanently. So let us see the types of memory. There are several types. So first is the RAM, and which is widely known as random access memory, and it is a volatile memory. It means it is a temporary memory. Once you store the data, and suppose if power is gone of your system, then your data will be vanish. So you can store your information in RAM for some temporary amount of time. Next is the ROM, which is the read only memory, and it is a non volatile memory, and it is also known as NVRAM. So means non volatile RAM, in which you can store your data or information permanently, whether power will be lost or not. BIOS is one kind of the example of ROM. Full form of the BIOS is the basic input output system. Yes, you know the BIOS setting which is available in computer system. When you are switching on your computer system, first of all BIOS setting will be loaded, which is stored in the BIOS ROM, and according to those setting the next operation will be performed. So this BIOS ROM is one kind of the non-volatile memory, which is ROM. So let us see some more types of memory. Next one is the PROM, which is known as programmable read-only memory. In this memory, you can store data using some program. But once you have written to the data to this PROM, you cannot wipe it or you cannot clean it. And its example is like a CD reader. Next one is the EPROM, which is the erasable programmable read-only memory. Yes, which is similar kind of the above memory, but in this you can erase the data using some ultraviolet light. Its example is the CD reader writer. Next one is the EEPROM, that is electrically erasable programmable read-only memory, and it is special kind of programmable role that can be erased by exposing it to an electrical charge. Yes, using the electrical charge you can erase the data and you can rewrite your data on the memory, and which is widely used, that is our pen drive. So that is one kind of the EEPROM. So this is all about the memory, various types of memory. Let us see some hierarchy of the various memory. Here you can see the one pyramid of the different type of memory. Ones on the top is register, then L1 cache, L2 cache, main memory, local, secondary storage, remote secondary storage. So if suppose you are going from bottom to the up, so your memory will be very faster, expensive, and it will having the very less capacity. And if you are going from top to bottom, it will be slower, more cheaper, and more capacity. As we know that the register having very less storage, but it is frequently used by the processor, and which one is very faster, and it is obviously it is very costly. L1 and L2 cage also having the less capacity but very faster than RAM and ROM, means our hard disk. Main memory is one ROM or RAM, and which is faster than the our secondary storage, which is our hard disk. Remote secondary storage can be another backup storage on a network. So this is shown the hierarchy that how the memory is faster, expensive, and capacity you can categorize. So next concept is the memory partitioning. How memory can be partitioned. So there are two different way of partitioning the memory. First is the fixed partitioning, and second one is the dynamic partitioning. So we'll see this two different concept one by one. So let us first see the fixed partitioning. So here memory is divided into the fixed size of partition. Just its name is fixed partitioning. So your full memory will be divided into the many fixed size of partition. So here is the one example. This is your total memory, and where some part is occupied by the operating system, and the rest of the part will be divided into some fixed number of partitions. So size of the partition can be equal or unequal for the different partitions. So here you can say it is equal or unequal. Generally unequal partition are used for the better utilization. Each partition can accommodate exactly one process, means only single process can be placed in one partition. Yes, in each partition only single process can be placed, and the partition boundaries are not movable. Once the partition is occupied or fixed, the boundary cannot be movable, means you cannot change the size of any partition once the partition is created. So that is fixed partition. Whenever any program needs to be loaded in memory, a free partition big enough to hold the program is found. This partition will be allocated to that program or process. Yes, suppose if any program or process want to access the memory partition, so first it will search out for the required space partition. If required free partition is available, then that particular partition will be allocated to the particular process. So if there is no free partition available of your required size, then process needs to wait, and that process will be wait into the some queue. If suppose process is coming and there is no free partition, then obvious the process needs to wait in queue. So there are two ways to maintain the queue in the fixed partition, using the multiple input queue, and another one is the single input queue. Here is the two different figures. First is of multiple input queue and another one single input queue. This is your memory, which is fixed partition memory. Here also, here you can say multiple input queue. First here is here, then second and third. So here three different queues are maintained for different partitions, so that known as the multiple input queues. Instead of here, you see that only single queue will be maintained for the all required partition. So all the processes will be weighted into the single queue. Whereas in this one, there are different queue where the each process can, for the each partition can wait into that particular queue. So these are the two different way to maintain the queue for the fixed partition. So this is all about the our fixed partition. Let us see the multi-programming with the dynamic partition. So how the dynamic partition concept will be or can be implemented. So here the memory is shared among the operating system and various simultaneously running processes. Yes, here your memory will be shared among the various processes which are running, and it is a task of operating system to share that memory with the ongoing processes. So let us see how the operation will be performed. So process is allocated exactly as much as memory is required. Yes, here is suppose any process coming, and whatever size required by that process, that size of partition will be allocated to that particular process, and it is task of operating system. So here we can see the diagram, that is your memory, some part which is already occupied by your operating system and another part will be occupied by the user program. So initially the entire available memory is treated as the single free partition. Yes, here is your single partition, not divided into this fixed partition. So whenever any process enters in a system, a chunk of free memory big enough to fit the process is found and allocated. The remaining unoccupied place is treated as another free partition. Yes, suppose if any process comes into the picture and want to occupy some memory, so that required space will be given to that particular process and remaining portion will be free to the other upcoming processes. So if enough free memory is not available to fit the process need to wait until the memory becomes available. Whenever any process gets terminated, it releases the space occupied. If the released free space is continues to another free partition, both the free partitions are merged together into the single partition. Yes, suppose if any process is finished its task and release its occupied memory, then it will be merged to the remaining free partitions. Better utilization of memory than fixed partition size partition. Yes, it is obvious. Here is the better utilization because as per the required amount of memory of any processes, the memory will be allocated to that particular process by the operating system. So this is the better than the previous one of fixed partition. So here is the one example that how the dynamic partition can be implemented. So in figure A here, some portion is occupied by operating system. Suppose process A is coming into the picture and A wants this much, this amount of memory, so it will be allocated to A and remaining will be free. Next, suppose B is coming, then this required amount of memory will be allocated to B and remaining portion will be free. Next, C is coming and then C, still we have the enough memory, so C will occupy this amount of memory, and currently 3 ongoing processes is A, B and C. Next, and here A is finishing its process, so this partition will be free. Now only we having B and C. Next, suppose D process is coming and it's require only this amount of memory, so initially it occupied this memory space, and then next B is also completed its task, so this memory will be also free. So this two continuous memory block will be merged and this single block will be created. Next time suppose A is coming once again, then this portion is enough to occupy to the A, so A will be continue over here. So likewise this dynamic partition concept will be implemented in operating system. Okay, when any process comes in the picture, then required amount of memory portion will be allocated. If suppose here there are 3 processes and suppose one more process is coming into the picture, then suppose if there is not enough space, then that particular process will be weighted into that waiting queue. When required amount of memory will be available, then next D process will access that particular memory portion and can continue the task. And keep in mind that suppose any process is completing its task, suppose here is the B, then that particular portion will be free and it will merge to the remaining space and will create a one continuous block. So this is the concept, the how the dynamic partitions can be implemented. The next concept, that is memory compaction, which is also associated with the previous concept of the dynamic memory partitioning. So here, when the swapping creates multiple blocks in memory, it is possible to combine them all in one big block by moving all the processes downward as far as possible. This technique is known as memory compaction. So here you can see the process operating system. Here is the total memory. This is process A and process B in memory. And what is memory compaction? Suppose here process A and process B is occupied some space in memory, and in between there is some free space which is unutilized. So memory compaction will what do here, this free memory will be merged to this free memory, and this it create one big block of free memory, and it will serialize this process A and B. So what will happen? So if any next process is coming to the picture and wants some memory, then it will having some huge amount of memory to complete its task. And if we are keeping this into particular different block, then suppose if any process is coming and suppose we haven't enough space in our memory, then that process has to wait in queue. But if memory compaction is doing, then what happen, all the processes and will be serialized in memory, and the remaining free space will be merged into the big partition, free partition. So any next upcoming process can be allocated that particular partition, so that will be more efficient than the ongoing. So this is all about the our concept of the memory management. Here we have seen the what is basic about the memory management, then we have seen the memory hierarchy, various types of the memory. Then next we have seen the two concept, which is the fixed partition and dynamic partition, in which the memory compaction. So this is all about this ongoing session. So goodbye all, we'll meet in the next session. Thank you.